All right, I think we're ready. Let's go ahead and get started. Anyway, I'm glad you're all here. I'm glad you're all here, and it shows me that you are taking matters into your own hands. Over the weekend, I sent an email about how email etiquette should be done. So make sure when you're writing an email, make sure you include your name, what class period you're from. Makes it easier for me to check you off on attendance or whatever, because you can check in pretty much any time during the day. I usually say the best time is in the morning so that I can get all the stuff sorted out. And if you miss any of the lessons, don't forget that I have my channels that you can go to and either catch up on the lesson or, you know, some people don't have good internet, so it's probably a good idea for them to just watch the videos whenever they get a chance. So let's go ahead and continue from where we left off. We are adding and subtracting radicals. So remember, the first thing we got to look for is we got to look for like terms. And in radicals, you're looking for like radicals that are numbers that have the same index and the same radicand, the number underneath the radical sign. So in this case here, for example number 9, I have square root 2, and over here I also have another term with square root 2. This means that they are like terms. When they are like terms, I just add the number in the front, the coefficient. So in this case, I have 2 plus 4, which is 6, root 2. Remember, the number under the radical does not change. Oh, got a ladybug on me. Weird, I haven't been outside in a while. Anyway, so we're done with that one. There's nothing else we can do. We can't simplify it. We can't add anything else. And we can't take the square root of 2, so we are pretty much done with that one. All right, and here's another one with something that we might need to review. So look at your like terms again. So radical 7, radical 7, radical 7, or root 7, however you want to say that. Root 7, yeah, they're all the same. So again, we just work with the numbers in the front. So 5 minus 2. So 5 minus 2 is 3. I really shouldn't be skipping steps, but in this case, we can just go 5 minus 2, which is 3. And if we don't see a number in front, it's going to be 1. So this would be 5 minus 2, which is 3, plus 1. So this would be 4 root 7. And again, there's nothing else we can really do with this. So let's go ahead and box that up, and that'll be our answer. Okay. Same thing, simplify each expression. So those two were some easy ones. These ones are a little bit more difficult because if we look at number 11, we don't have like terms. The radical of one of them is 3 and the other is 12. 3 and 12, so we can't add them? No. In this case, we're going to have to do a little bit of work in order to make it usable. We are going to have to, well, with this first one here, there's nothing we can do, so let's just go ahead and leave that one as is. But 12, we can go ahead and do something with that one. In this case, I'm going to use the prime factorization, and that is to either, you can think of it as dividing or thinking of two numbers that will multiply to 12. So I think the more common method that we've been using is to try and find a square number. So in this case, 4 is a square number. So what we're going to do is we're going to, oh yeah, and don't forget that these things are under the radical. So this is actually root 3 times root 4. But we can take the square root of 4, so that's what we're going to do. Square root of 4 is 2. I'm just going to kind of put something there so we know that it's different, it's something else going on. But anyway, now we do have two like radicals of root 3. So we had to simplify it first in order to get to where we can make them like terms, and then we add them together. So 2 plus 2 is 4. And remember, the radical doesn't change, so it's still going to be root 3. There we go, not too shabby. All right, let me just update my attendance. I'm missing somebody. Oh well, I'll catch up on that later. Today is kind of a weird day. I'll explain probably after this one. Hopefully you had enough time to write it down if you're following along. So 5 root 2. So again, there's nothing I can do to that one. I can't really break down 2 into any numbers. But 18 we can, so I want to make square numbers. And if you don't do the way I've been showing you now, we're going to have some more numbers that are a little bit more complicated than some of these ones by the end of this lesson, and probably into the next one. We're going to have some that are pretty difficult. So I'm going to show you another way, even though normally I would break this into 2 and 9. Let's say that we did 3 and 6. All right, because some of these numbers you can't really tell right off the bat what their best factors would be. So sometimes you just got to get started and just keep dividing, right? You want to get to prime numbers, numbers that cannot be divided anymore. So in this case here, I have a pair of 3s at the bottom. So when you take them out, there is only going to be 1 3, or a full power 3. Because remember, everything under the radical is a half power, or if the index is something else like 3, then it would be a third power. But anyway, now our indexes match, our radicands match, so we can go ahead and add these together. 5 plus 3 is 8. Are you serious? Let me check. I'm not. If you can't hear me, check your volume. Unless anybody else is having trouble hearing me. Anyone else? Are we good? Okay. So I got. it might just be on your side. All right, I'm getting people. So if you can't hear me, check your volume, check your systems on your end. Unless, of course, I don't know, something else is going on, but I wouldn't know what that is. All right, so how many more do we have? I think we got this one and one more, and then we'll be done with this lesson of adding and subtracting radicals, and then we'll move on to multiplying radicals. So new packets are out this week. I think almost everybody was picking them up. I had some people pick them up on Friday. It's been a pretty busy morning out front. I think people have been picking up their packets. Make sure you return your old ones and drop off your, turn in your old ones and pick up a new one. Okay, so anyway, back to here. Now these ones are subtracting. I think these ones are a little bit more tricky because something else can happen on some of these. So 20, and again, not everybody would be pretty good at figuring these out. So I'm gonna show you a different way. Normally I'd break it into 4 times 5, which 4 is a square number. But if you don't do that, that's fine. You just have to keep using the factor tree, which in this case, I do manage to get all of it factored because 2 and 10, neither of them are square numbers. But if I completely factor it, I can see that I have a set of 2s, a pair of 2s. So I'm going to take those pairs out of the radical. But the 5 stays in there. I can't do anything to get that 5 out of there. But that's okay because I got my other term, which is also a root 5. Now I have 2 root 5 minus root 5. So remember, if you don't see a number in front of your either your variable or in this case our radical, then it's assumed to be 1. So it'd be like 2 minus 1, which would be 1 root 5, but it says simplify, and that usually means put it in the simplest form possible. So in this case, if I had 1 root 5, we don't need that 1 because it's already 1 times anything is always going to be that same number, so it's not going to change anything. It makes no difference whether it's there or not. But since it says to put it in simplest form or simplify it, that means that we take care of it. We try to have as few things as possible. If you see any multiplication, division, addition, roots, powers, anything that tells you to do something, make sure you do it, because that's what simplify means. Same is true for evaluation, but sometimes it's a little bit different. Okay, number 14, 2 root 6 minus root 54. All right, with this one, it does not look like there's anything I can do. So I'm going to go ahead and leave it as is. And now for 54. Now again, these numbers are going to start getting a little bit bigger, so it's probably easier to use full-on prime factorization instead of just looking for square numbers, which again, both methods work. And I'm showing you both so you can pick which one you want. So let's go with 2 times and then 54 divided by 2. So that'd be like 25 plus 2. So that'd be 27. And now we need to break 27 down. So if it's an even number, it's pretty easy to factor it out because any even number can be factored, can have a 2 factored out of it. 3 and 9. Is what you use to make 27, and 9 is 3 times 3. Now again, if you remember from the last class, I was talking about getting a clue and that you should look for 6. So in this case here, I mean, if we were looking for that, we would have immediately known that we were going to get 6 in that radical. But again, I'm showing you a way that you, I'm showing you a way so that way when you have bigger numbers or if you're not sure how to factor it, then you can just kind of go this way, the long way, where you see all the numbers and you just pick out the factors that you have extras of. So in this case here, I have a pair of 3s, and I'm going to take that out. And I also have 2 and 3 that are still in there, 2 times 3, because they're all being multiplied to each other. But we don't need that 2 and 3, right? We are going to need a 6. I'm going to put them back together because I want it to match this one. Now that they match, I can put them together. So in this case, looking at the front number, 2 minus 3, and we get -1. But kind of similar to this one here, I don't really want the -1 because the 1 doesn't really change anything. It doesn't really do anything, all right? It's kind of like putting Legolas in the Hobbit movie. There was really no reason for him. He was just extraneous and didn't really do anything to serve the plot. And in some ways caused continuity errors in the entire movie series. But sometimes you just don't need something. So let's just leave it out. All right, and that's it for that one. Last one, I know this one's gonna have a couple of tricky ones on it. Okay. All right, so with this first one here, it doesn't look like there's anything I can do to make it more simple. So chances are that's what we're just gonna have to work with. And again, if you see that there's a clue, then that usually means that we have a 3 in here. So I think that is probably still, I'm gonna go back to using it the other way where we're looking for square numbers. So in this case, we have the square of 9. So I'm going to take the square root of 9. And I have 3 right here. So 3 still in the radical. And I run into the same problem where I end up with a negative coefficient. 2 minus 3 is a negative number, so we have negative 1. But again, we don't really need the 1 because it doesn't really do anything. Kind of like when grocery stores wrap fruits in plastic, or like oranges or bananas that like already have their own natural packaging, and for whatever reason they want to wrap a orange in plastic. Well, I'm pretty sure nowadays it probably would make a little bit more sense to do something like that. But I remember that was like something people did a long time ago, like even like 4 years ago. Anyway, so with this one here, it looks like we have 2 of them that we need to simplify. Now this one should be an easy one because we are using an example from a number that we've already had before. So I don't have to do anything to this one because I can look right over here and see that it is 3 root 3 minus, and then 12, same thing. I'm going to break it into 2 numbers that I know, and one of them being a square number. And remember, this is the square root of 4 and 3. Which means that I have to take the square root of one of these. Square root of 4 is 2, and 3 stays in the radical. There's nothing I can do to get it out. And in this case, it looks like it's almost the same problem over here, but it's a little bit backwards. The order has been reversed. This one is 3 minus 2, so we're going to get positive 1. But we don't really need the positive or the 1, because if we don't see a negative, then we know it's already going to be positive, so we don't need to complicate things anymore. Right? I mean, math is already confusing enough. We don't need to make it more complicated. Well, sometimes we have to, but especially when giving the answers, we should always try to keep things simple as we can. Okay. Looks like we're doing pretty good on time. I'm going to go ahead and move over to the next thing. So that was our review for today. Let's go ahead and move on to what we're doing today. So what we're going to do today is we're going to multiply square root radicals and simplify radicals by using the quotient rule. So we've been simplifying radicals, so it's not too big of a deal. It's not that much different than what we've been normally doing. But the multiplication, I think, is a little bit different. But I think when it comes to rules, I don't think it's that bad. I think, you know, maybe seeing it once or twice, it'll start to make sense, and it won't be something that you have to work a lot for. But anyway, those are the learning objectives for today. So it looks like we're going to have to do a little bit of definition. And a lot of these definitions, again, don't be afraid, because even though they look pretty complicated, they're usually pretty simple. And a lot of this stuff is just sort of extra stuff that they throw in there. And sometimes if you're really paying attention to them, you will run into special cases, or sometimes you'll be working on something and then it'll change. So once that happens, you know, you've got to have some way of knowing what's going on. So basically all this is saying is that for any real number, so again, this is just for any real numbers means it could be anything. So with these two numbers, pay attention to the index, because the index is the same, right? They are n. They could be square root, cube root, fourth root, or so on, right? So they could be any number, but as long as they are the same, then you take the radicand. In this case, a is under the radical, b is under the radical, and you just multiply them together. So there's two different things going on here. There's 1 and 2. Now, with this one, this first one, this is something we've been using for a while. In fact, we just got done using it on pretty much all of the examples from the last slide. And I'm trying to think of a really good one, but I'm just going to go with the one that comes off the top of my head. So like, for instance, when we take the square root of 18 and we simplify it, so the index is there, I have a number, but I'm going to break it into two numbers that I can multiply to get those numbers. So in our case, we had something like 3 times 9. Oh, wait, no, 3 times 6. 2 times 9. What am I talking about? Here, I said that I was going to go with one that I just remembered. And if you remember from the very first day that we actually started working on these kind of problems, we starting to get a little bit ahead of myself. I did the first couple examples kind of this way here, because again, every single time you do something like this, you can break them apart. And then here I'm going to switch the order so that it's instead of, I'm going to just reverse it. So instead of root 2 times 3, I'm going to say 3 root 2 or 3 times root 2. But if you, again, okay, I kind of messed up a little bit on that one, but if you just go back to what we were working on just a minute ago, like in this case here, this 54, yeah, we just broke that apart using the exact same rule. We just took the number apart so that we can work with it a lot easier. But what we're going to do now is we're going to go back and we're going to take the pieces and kind of join them together into something bigger. So it's the same process. You're just going back and forth pretty much. And math becomes a lot less complicated when you think about it that way, when it's the same thing but backwards. You know, people are, every time I always get math classes, they're always like, oh, but math is so hard. There's so many rules. No, it's not, there's not that many rules. It's the same thing, but just backwards, you know? Okay, I can understand maybe driving a car backwards is a little bit more difficult than driving a car forward. But it's not really like an entirely different thing. It's not like you turn your car in reverse and all of a sudden you're driving a tractor or a crane or something like that. It's the same thing, takes a little bit of getting used to it, but it's a lot less intimidating when you just realize it's the same thing, just going backwards. Okay. So we have a couple of these. I'm not sure with my other classes, I was actually able to finish this entire slide. It's not a very long lesson. Okay, it's not really that long, and it's pretty intuitive, so it makes a lot of sense when you think about it. But we just want to multiply the number. So if we pay attention to the rule that we had, we're going to multiply. Well, actually, let me multiply the regular numbers first, our coefficients. So in this case, we have 6 times 3, and that's going to be our number in the front, which is going to be 18. 6 times 3 is 18. Now I need to multiply the radicals to each other. So in this case, root 2, root 10, and I get root 20. All right, but I still need to simplify it because the direction says to simplify, which if I can simplify this 20, then that would probably be a much better idea. So I multiplied these two numbers together, but I'm going to have to work a little bit to take them apart again. So 2 and 10, again, those are some numbers that work out, but I'm going to use 4 and 5. And this is kind of that same property that I was talking about earlier. When you break down a number in a radical, right, it's the same thing as going like this. Now, again, I don't want to overly complicate things, because I think so far we've been pretty good at understanding some of this. So 18 times root 4, which again, we can take the square root of 4, which largely I have been skipping this step lately. But we are able to take one of the numbers out from the radical. And when we do that, we just have to remember to multiply them back out together. So 18 times 2 is 36 root 5. And it doesn't look like there's anything else we can do with this. No more simplifying, no more operations. So that's it for that one. Now don't get confused, because I know it looks like when you see these lines, it looks like you're multiplying something pretty complicated, but no, it's just whole number to whole number or coefficient to coefficient times each of the radicals together, and then try and simplify it again after that. All right, it looks like this next one has a root 3, a cube root, right, and an index of 3. So when we take that number apart, we're going to have to look for 3 numbers that match, that will multiply to get whatever number we get. Now, there is somewhat of an easier way, but the problem with easy methods is that sometimes they might be hard to learn, and they become easier to make mistakes with them. So for now, I'm just going to stick with kind of the long way around. So let's do the same thing, coefficients to coefficients. So in this case, I have -5 times -4. Now, if you remember, a negative times a negative is a positive. So -5, -4, put them together, you have 20. Now, I still have to multiply this under here. So 4 times 6, which in this case, 4 times 6 is 48. And we're still taking the cube root of it. So yeah, we're still taking the cube root of 48. Now, 48 is not a cube number, so it's not like there's anything I can really do to clear it up. But we can factor it and see what we can take out. Now again, there is that method that you can use to get square numbers. Well, in this case, we want cube numbers. Now, the reason why I started teaching this method earlier from the last lesson is because, again, if you're using like cube root, it's a lot easier to fully get the prime factorization, to fully factor the number first. That way it allows you to see all of the numbers. Now, another thing that's pretty good to get into the habit of is to get the smallest factors out. So 2 and 24. Now, when you do this, your numbers are going to be in order, so it's easier to group them. And I'm going to break 24 down into 2 and 12. Break down 12 into 2 and 6. And 6 can be divided by 2 and 3. Now, if you look at the bottom of my factor tree, these are the pieces that I'm looking for. And again, I'm looking for numbers that will give me 3 of a kind. So in this case here, I have a group of 3 2s, and I will have some of these numbers that stay in there. There's nothing I can really do to take them out. But since I have a group of 2s, they are going to come out. And I'm going to put these numbers back together, the 2 and the 3, because I don't really need them separated. I don't really need them apart. And again, if you see any operations like multiplication, then do those also. Otherwise, it's not in simplest form. Now I have these numbers because this 2 came out. That means I have an extra factor of 2 that I'm going to take out. So in this case, 2 times 40, because I just need to combine it with the outside number. So if you remember when we were adding radicals, and if you take numbers out, it's going to multiply to that. And this is what we did, like, I don't remember when exactly this was. I think it was Friday. So in this case here, if you have numbers that come out, there's a chance that it's going to multiply to that number. So in this case here, like, okay, and I know this was a while back, and I think this is a pretty good example here when we took this out. All right, so certain things come out and there's already numbers on the outside. So when you simplify them, it can increase your other numbers. But in this case, it looks like there's nothing else we can do. So I'm going to go ahead and box this up and call it the answer. Stretch. All right, there we go. Well, there is one kind of downside is that during all this, again, teachers don't usually do a lot of moving while we're stuck in the building. And they don't want us walking around too much. And so I feel the need to stretch probably a little bit more often than I would if I was walking around. But even just sitting kind of gets boring, takes a bit of a toll on you, I guess. I don't know, my back, I wouldn't say it hurts, but you know, I mean, I can feel it in my back when I get home later. It's like, I don't know, I'm not moving or anything like that. Maybe I should get a weight set and I put a bench press bar over there, and maybe a sit-up thing over there. I'll turn this place into a gym. No, I'm kidding. Maybe put a treadmill in here too. You know, that would actually be a really good idea. That way I could get some walking done. Normally during like normal hours, I'll just walk around in the hallways sometimes, but now they don't want people walking around in the hallways. Well, probably not just unnecessarily walking around in the hallway. But anyway, let's go ahead and get into the next one. So 10 times 4, again, whole number times whole number. Well, sometimes they're not whole numbers, but I mean coefficient. So 10 times 4 is 40. Now I need to multiply the radicals together, which in this case here I have 6 and 3. So let's go ahead and put those in there. 6 times 3 is 18. Now in here I also have a variable too. I have a set of variables. I have p to the 3 and p. And if you remember from last week's Wednesday lesson, if you don't see a exponent, then that exponent is 1. So in this case here, I have p to the 3, p to the 1, and you add the powers together. When you multiply numbers that have powers, you add the powers. Don't multiply them. We add them. There you go. So p to the 4. Now, we start simplifying our radical as much as we can. Now, in this case here, well, maybe I'll write it out. Remember what I would say is when in doubt, write it out. So I'm gonna do that right now. So I'm gonna factor 18 into some numbers that I can easily break down. So 2 times 9, and we also did this like a slide ago too. So I think I used that as an example. So it's kind of already there. And we end up with, again, p to the 4. So p times p times p times p. So I end up with 4 of these, and I'm going to look for groups. In this case here, I have a square number. So I can take the square root of that 9, or if I broke it down more, I get like 3 times 3, which would be like the same thing. And then I'd have a set of 3s I could underline. But I'm going to take that out, and I'm going to take a set of these out as well. I have 2 sets of p's actually that I can take out. So we're going to take all the underlined pieces out. So 40 and times 3, because again, we took the square root of 9. And I have 2 sets of p, so I'm going to say p square. There was 4 of them. But again, we take divide it by the index, which if you don't see an index, it's going to be 2. So that's one of the other things we covered last time. And we are going to have some stuff left in there, like for instance, this 2, right? That 2 is stuck in there. We can't really take it out. So let's go ahead and multiply what we have. So 40 times 3 is 120, p squared. And leave a little bit of space in here or put a dot in there. And that just shows me that, that the 2 is not the index, but it's the power of the p. Or I should have said the exponent of the p. All right, there we go. And we're done with that one. And this is not a particularly long lesson. But like I said, this is also one of those concepts that I think are kind of on the easy side. So far, there hasn't been anything that's really new, different, or anything like that. And again, it kind of fits in with mostly what we already believe. All right, so let's do this one. This one has a 4th root index. So 2 times 3, multiply that out, you get 6. And 4th root, so we're looking for groups of 4, so we're looking for pretty big groups. Now in this case, I have 20 times 28. So 20 times 28, so 2 times 28 is 56. Put the 0 back on, and I have 560. And y squared times y to the 3rd. And again, remember, when you're multiplying numbers with exponents, you add the exponents, so they're both y. So that'd be y to the 5th. So I got quite a lot of stuff under there. Now, I did say earlier that sometimes it really helps to do the entire prime factorization, because if we start breaking down 560 and we're taking 4th roots of it, it's going to be really tough to look for 4th root numbers. I mean, if I ask most of you guys to name a 4th root number or a 4th power number, you probably couldn't really do it. I mean, the only numbers you really have are like 16, 64, and even I don't know that many that many numbers of that kind. But we do have an easy way, and that is to take the full prime factorization. And again, that means breaking the number all the way down into as many pieces as you can. And again, start with the smallest ones, which is usually 2, which 560 is an even number, so I know it can be divided by 2. So 56 divided by 2 is 280. And then 280 is also an even number, so I can divide it by 2. So in this case here, it's going to be 28, 14, or 140. Again, even number, so let's divide it in 2 again. 140 divided by 2 is 70. 70 is an even number, so I can break that down into 2 times 35, and 35 can be broken down into 5 times 7. Now, I don't get a full even set of everything, but I can tell now just by looking at it, I have the whole thing all taken apart. And by doing that, I have a set of 4 right here. And when you do what I was showing you, where you take out the smallest factor possible each time, you actually get you actually get the number in order, the prime factorization in order. So it's a lot easier to spot groups. Not that we would really need the help of spotting this many number 2s, but you know, it is what it is. So let's take out this group of 4 number 2s. Like when I go to McDonald's, I get 4 number 2s. Not really. Oh man, I ate this. I'm gonna get off on a tangent here. But anyway, let's get this y out of here. So I got 5 y's, and this sign says I need 4 of them. So I'm gonna take 4 of these out, which leaves 1 in there. So take this. Now we gotta find out what's left in there. So from 560, we took out all the factors of 2, which leaves us with only 5 and 7. So that means This is going to be 35. And like I said, there was 5 y's, but we took out 4, so that leaves 1. So 1 y is still going to be in there. And multiply this here, 6 times 2 is 12. 35y, still in the radical, make it a little bit longer, a little bit nicer also. There we go. And we are done with that one. Now I had to finish that one here, but one downside to getting older is that food affects you a little bit more than it normally would when you were a kid. You know, when you were a kid, you could probably eat hot Cheetos and cupcakes before bedtime, and it wouldn't have affected you. But I finished this. I finished a big KFC box. It's like the number 10 or something like that. It's got like chicken tenders in it and a big box of fries and a biscuit and some coleslaw. I think it was actually a family meal because when I opened it, there was like 6 or 7 chicken tenders in there, and I ate all of them. Now I'm like not just full, but I can feel like salt in my veins now. Kind of like I saw this meme the other day where this guy's looking at a bag of chips and it says family size. And then it has that guy from Spider-Man who's the Green Goblin. I forget his name. Osmond or something like that. Anyway, he's that guy that's kind of like that older guy who played the Green Goblin in the old Spider-Man. He's like, you know, I'm something of a family myself. That's true though. Family size, just, I don't know. Eat it. You can just eat it all by yourself. But yeah, that was a lot of KFC though. I'm regretting it. All right. Back to work now. I have multiplying radicals. Now this one's a little bit different. There is a plus sign separating these two things. So if you think back to, let me make an example here. Like if I have 3 times 5 minus a. So I did say that you can treat these radicals kind of like variables. Now in this case here, I used a minus, but we can use our distributive property to reduce this. And there's a lot of different ways you can approach this kind of problem, but I think the best way is to just sort of just use the properties they tell us to, because sometimes things happen that they know about, or they might know what's going to happen, but we don't. All right, so I'm going to go ahead and multiply root 6 times root 2. And I get root 12 plus 6 times 18. Now 6 times 18, let's see, that would be 12 times 9. I don't know what that is either. Yeah, I'm going to cheat a bit and use my calculator. 6 times 18. Okay, I thought it was that, but I wasn't sure. 108. I got to be careful. Sometimes I make mistakes, which so far I think I've been pretty good about that. Other than just like a writing or a typo or saying the wrong thing when I'm writing something else. I think so far I've been pretty good on most of these. All right, so now we should factor these out and see if we can combine them the same way we did with the last lesson, the way we did in our review. So let's go ahead and break down 12, which if you remember, 12 is 4 and 3. 4 times 3 makes 12, but we can take the square root of 4. So square root of 4 and 3. And like I said, if you were paying attention, if we can get this to work, if I do the factorization of 108, we can look at the clue, think ahead, and let's try going by 3 on the first try. And 108 divided by 3 is, I said divided by 3. 108. Okay, calculator, come on. Divided by 3. So that would be 36. And that's very helpful because 36 is a root number. So I should be able to take the root of 36. So 36 root is 6. And there we go. We have a root number left in there of 3. Now we have 2 like roots that we can easily put together. Now again, I don't know if you could have added these together, and I don't know what difference it would have made. I think if I had a little bit more time, I would try it out and see if we get the same answer. But now that I'm thinking about it, I think you'd have to do a little bit more work to make that work out. But anyway, add the coefficients 2 and 6 together, you got 8. And again, our power doesn't, the radical doesn't change here. And that's it. Okay, now, let's see, I think I did this problem this morning and it came out kind of weird. So I'm gonna pay a little bit more attention to this one because I don't know if I made a mistake or anything on it, but this one does have quite a bit of things going on for it. So we're gonna have to multiply both of these by the root of 9. So I have a regular number, a whole number, times a root number. And that's pretty easy. That means they're not really going to affect each other. So I just put them together. Because again, it's a like whole number times coefficient sort of thing. So if I don't need to take them apart or do anything else, just put them together because they're 2 entirely different things. Minus, now I'm going to use my calculator for this one. I can do a lot of math in my head, but I'm not gonna take any chances with this one because, like I said, I did it before and I got a weird number. I think it was this one. I'm not sure if it was this one. All right, so cube root of 162. Now I'm gonna see if I can break this down into a number that will give me 9. So I'm gonna try that at 162. And I'm going to bring my calculator up and divide by 9, which it does. 9 and 18 work out. 9 times 18 is 162, which makes sense because well, I could also break 18 again into 2 times 9, which would give me 2 factors of 9. 2 times 9, like that. Now I have the square root of 9 and the other square root of 9. Or I could multiply them together. 9 times 9 is 81, and take the square root of 81, which is 9. Or again, I have a pair of them, so that would be 9 root 2. I did this one a little bit different to make sure because if I did it the same way I did and it didn't work out, then I'd second guess myself. But in this case here, again, 9 managed to come out because I have 2 of them, but when you take it out of the radical, then you only have 1. I thought there was a way I could get 9 to stay in the radical, but it didn't quite work out. And if you've ever taken my class before, you know, sometimes I just say, sometimes it be like that. All right. With all of these problems, we managed to get like radicals, and with those like radicals, we can continue combining them until they make something better. But in this case here, we don't get like radicals, and sometimes it be like that. So there's nothing we can do. We can't add them together, so we're just going to leave them like that. And that is the simplest way we can put it. I cannot do anything to this. I can't do anything to that. They're just 2 different numbers, and that's just the way it's going to be. Now, I do want to leave some problems for tomorrow for the review like we always do. But I also want to make sure that we get some of these covered. So if you want to start the homework now, you can get a start on it. But I also want to save some for tomorrow. So let's go and do some that are a little bit on the tricky side. I think these are going to be the ones that will probably give the most issues with when trying to work it out. Okay, moving on. Okay, these ones are very different. So on the last one, we had a parentheses with like a minus or an adding in the middle. But here we have a parenthesis with two terms. We call that a binomial. And over here I have another parenthesis with also two terms, which is another binomial. So we got some binomial times binomial stuff going on here. And we're gonna have to use a little bit of fancy work. If you remember Algebra 1, which I know might have been a long time for most of you guys, we need FOIL. Now FOIL is a way of memorizing some steps, because what we do need to do is we need a strategy, kind of like a guideline to follow, because what's happening is this 3 here needs to be distributed just like we did distributive property on the last slide. So distribute the 3 and distribute this number here, the second number in the first group. And there probably are other ways to do this, but I think FOIL is probably the most common, and it's also the most like it comes with a nice little way of remembering it. So like FOIL, like, oh no, my plan is foiled again. If I would have gotten away with it if it weren't for you meddling kids. But now we can easily see that there are some steps. So FOIL, F stands for first. So that's the first number in each group. So in this case here, my first number is 3 and 4, which is going to give us 12. And here I have the outside, which is the second step. So outside numbers are the two numbers farthest apart from each other. And be careful with these ones because when you have a negative, that negative is part of the problem. So this is negative 2 root 7 multiplied by 3. Now, in this case here, I look at my regular numbers. So 3 and 2 make 6. And I'm not multiplying root 7 by anything, so it stays the way it is. I don't need to change it because I have no other roots on the first one. So that's our second step. Third step is the inside. So those are the two middle numbers, the two numbers on the inside, which in this case I made it orange. And let's go ahead and multiply that now. In this case, again, that negative does matter. All right, it's not the same thing as like say 3 minus 2 root 7. It's 3 and negative 2 root 7. So don't forget that. Any time you have a negative, those negatives do follow those numbers around. So multiply the numbers 2 and 4 together. So 2 times 4 is 8 root 7. All right, and now we have our last number. So L in FOIL is for last. So that means the last number in each group. Now in this case here, I have negative times negative. So since I have a negative times negative, that's going to turn into a positive term. Multiply 2 together, so 2 times 2 is 4. and root 7 times root 7. Now, in this case, since I have both numbers with roots, the roots will multiply to a larger number. So I end up with root 49 because 7 times 7 is 49. And now begins the work of simplifying it. So we multiplied all this together. Let's see what we can combine and make it a little bit easier to work with. So 12, okay, this 12 looks pretty straightforward. Doesn't look like there's anything we can do. But I do have two like terms with similar radicals, so I can put those together, root 7, root 7. So what I'm going to do is I'm going to add the numbers that go in front of the root 7, just like we did before. Now, in adding, don't forget, a negative and another negative make a bigger negative, so it's not like multiplication, where two negatives make a positive, right? So it's like if something bad happens to you and another bad thing happens to you, they don't usually cancel out. They make it worse. So if something bad happens to you, like, I don't know, Bay breaks up with you and then you get sick, that's two bad things. They don't cancel each other out. They stack up in how bad it is. All right, now with this one here, I have the root 49, which we can take the square root of 49. Square root of 49 is going to be 7. And that gives us 4 times 7. And we can still work it out. So I haven't run into anything that will make me stop yet. But we can take the square root of, I'm sorry, we already did take the square root of 7. Let's combine 4 and 7. So 4 times 7 is 28. And that gives me a whole number. And I have another whole number here, so I have like terms. So like terms don't have to just be same variable, same power. They can also be regular numbers as well. In this case, they have no variable, so that makes them the same. 12 and 28, so that would be 40 negative 14 root 7. And in this case, there's nothing else I can do. I have no more like terms. I can't take the square root of 7, or I can't even break 7 down into any numbers. And there we go. All right, now I'm gonna probably stop it right here. Hopefully you can try some of the homeworks, but if not, we'll probably continue this in the next lesson. But if I had a little bit more time, I'd do one more from the next slide. And the only thing I'm going to say about that one is with the square, what that means is since the square is on the outside of the parenthesis, it means I have two of those things. So in this case, I have 2 plus root 3 twice, so I have actually 2 groups of that whole thing. And you would do the same thing. So you would use FOIL again. But again, this should be enough to get you started on the assignment. If you get stuck on one, we'll continue it tomorrow and hopefully answer any questions that you might have had. But again, I like to keep these videos a certain length, so that will be it. Make sure you reply and tell me if KFC gives you a headache if you eat lots of it. All right, anyway, that'll be it for this lesson.